rule that says that if I have product of two functions, f times g, and I want to take the derivative, the product rule says I have the first times the derivative of the second plus the second times the derivative of the first, or some other order, since it's multiplication is commutative and addition is commutative. As long as you take the derivative of one and not the other, and then vice versa, you're good to go. So let's look at some examples. Let's say I have y equals x cubed times cosecant of x. So here's one function, here's the other. When I do the product rule, I'll have x cubed times the derivative of cosecant is negative cosecant x cotan x plus the second, make sure I don't run off, cosecant x times the derivative of the first, 3x squared. Now, typically when I do this sort of thing, I'm going to put this in front because 9 times out of 10, this 3x squared is going to get sucked into the cosecant and just screw up my day. So I'll probably typically write this as negative x cubed cosecant x cotan x plus 3x squared cosecant x. And there's my derivative. If I need to simplify it or factor it, I can do that, but if I'm just taking the derivative, I'm done. Okay. Let's try another one. You know what, this would be easier if I just ran it through, so that's not a good example. Let's try another one. Yeah, that's gross enough. I really don't want to multiply it out. And if I just want the derivative, then I will say y prime. I have the first. So copy all that down, 3x plus 2. The derivative of the second is 5x to the fourth minus 12x cubed. Plus, now I take the derivative of the first one, 2x plus 3, and leave the second one alone. X to the fifth minus 3x to the fourth plus 5. And there's my derivative. What if we have more than one thing multiplied together? Suppose I have y equals x times x squared minus 3x plus 2 times cotan of x. And don't be smarty pants and say I can just run that x through. Let me do my example. Be good to me. Okay, so y prime. I've got 3 terms here multiplied together, so I'm going to have 3 clusters. I will have one where I take the derivative of the first one and then leave the other 2 alone. Then I'm going to leave the first one alone, take the derivative of the second one, then leave the first 2 alone, and take the derivative of the last one. And the derivative of cotan is negative cosecant squared of x. And I probably would have run the negative in the front, but there's my derivative, and I'm done. When we have some more functions and the chain rule and other things, I can do more practice problems that are a little bit more interesting than these. But for now, these are a couple of practice problems for you to check out.